These are the instructions for your project assignment number 4, where you are going to make graphs and collect the summary stats for your particular project question. So on Canvas, let me go to Canvas. Log into, again, my mastering lab so you can open StatCrunch. If you get this sign in, then message sign in if you're not already signed in. And you're going to, well, let me sign in. You might automatically be signed in. So you're going to look at my my data. That's where you saved your data from the previous assignment. So if you have not done the previous assignment, you have to do these in order. So select that. And of course, I have many options here, but you should only have one unless you made 2 different ones. So then you select your data set. Now, as the example, I had, if there's anything that opens here, you can close it. I had selected the question, how many haircuts does an LAM student get per year? So the first thing we're going to get is the summary statistics for the entire class. So we're not going to be using the gender information just yet. That's for a later part of the assignment. So we're going to look at where the question is listed. So the next thing I'm going to do where this question 35 is, I'm going to put what these number represents. So this was haircut. So number, I'm going to put the hashtag number and then haircuts. And I'll get out of there so we could save it. In fact, I'm going to go edit, data, and then just save it. So I want that saved. Okay. Again, pause this video at any time. So if you're not too sure what to put here, let me say I pulled up the survey. How many pairs of footwear? So this student would say number of pairs. How many times? You'd put number of times. How many number of cell phones. How many units, number of units, so forth. How many times, number of times. Number of siblings, number of hours, number of books, number of drinks, number of hours, textbooks, number of classes, number of times, number of piercings, so forth. If you don't know, what to put, then, email me and with timely manner, give me a couple of days. Okay, so the first thing I want to do is this, once you've renamed this column, is to get the summary stats. So you're going to go to this tab, stats. You're going to scroll down to summary stats. And our data happens to be organized in columns, not rows. So select columns. And then I'll give you 3 options. We're not doing gender just yet. There should only be 3 here, because those should be the only 3 you have data. If there isn't, then something happened where you maybe you're not labeling it correctly. Again, view the previous assignment. Okay, so select the number of times, number of haircuts, number of shoes, etc. Compute, and then select compute here. You don't have to change anything else. Like in some of your problems, you might just select mean or standard deviation if that's the only thing you need. And then you're going to go to, once it computes it, you're going to do options, save. And it's already saved as summary stats, so I'm going to leave it like that. So save. And I'm going to close it because it saved it under my results. So if you ever want to come up with your results, you can. If you don't want the hassle, you could go ahead and maybe open a Word document or a Google Doc and just like before, snip this or screenshot it and place it onto your Word doc before you close it. But before I do that, let's see. The mean number of haircuts that a student gets per year is 5.9 if I had rounded to 1 decimal place, so almost like 6 haircuts per year, give or take 8.8 haircuts. So there's a lot of variation there. That's the standard deviation. The median is 2. That's if we lined everybody up from the lowest response to the highest response, and the person standing in the middle, I would choose their response. So whoever's in the middle, from once I order you from lowest to highest, that person's response is that they get 2 haircuts per year. seems kind of low, but if I sort this, sort table ascending, well, I don't want to sort it here. Let me do Control copy, just for demonstration purposes. Rid of this. If I were to sort this just to see how many, like visually, how many zeros I had. So I just chose sort it, ascending, going up. You could see that, there's a lot of low numbers, zeros, a bunch of zeros, ones, and twos. Oops, sorry. And there wasn't that many high numbers, like, more than one time a month. So it would make sense, like the middle of the pack would be somewhere in the twos. So that's what the medium is versus the mean, which is, adding all the numbers up and dividing by the how many students answered my question. So the number of students that I have in my data set is 35 that answered this particular question. Yours might be different. You might have had 34 responses or 36 or what have you, depending on how many people decided to answer your particular question. And then here's the spread, the range, the overall spread. So the difference between the smallest response, 0, and the highest response, 36, 36 was 36. So there's a 36 number of haircut spread between the lowest and the highest response. This was the smallest response, the highest response, and then the first quarter and the sixth quarter. So that's going if the with the box plot and using the medium as your best measure of spread. This represents like the middle 50% of the data. So half of the students' responses, when I lined them up from lowest to highest, fell between 1 and 6 haircuts. So notice what I'm doing. I'm analyzing this data because when you write your project, that's one of the things you're going to write under this section of summary stats and all these graphs. You're going to summarize that. And then just talk about what you found. And so kind of like the things I'm saying is what would follow these little charts here for the first part of your project. And you'll have practice writing that as well. Okay, now that I've saved it, I'm going to close that. And then the first thing we're going to do is make a histogram. So you're going to go to graph, scroll down to histogram, and just select that, just tap it. Number of haircuts. We're just going to keep it as frequency. If you want to play with the binning, you can, but you don't have to. I like to write how many responses were of each bin. So I'm going to mark the value above the bin. And then we're going to fill out something extra that we wouldn't normally do for StatCrunch. Since this is a project, we're going to add a title to it. So just click in there. And then your title should be the same thing as your title of your project here. So how many haircuts does it LA? And you should have the LAMC in there, and student get per year instead of you, like the original question. I'm going to copy this, so maybe I don't have to type it in later on. The X on a histogram is the student's response. So for mine, it's the number of haircuts. Yours can be the number of shoes, the number of times they went to Disneyland, whatever. You could just put a number of times for that. The Y is saying how many, so I'm going to click in here, the number of students that responded to each bin. Okay, pause it if you need to pause it to catch up on that. And then hit compute once you're done with that. So here's the student's histogram. Notice the number of haircuts are down here. So up to that last one, that was 36 here. It doesn't show it. Maybe the binning I don't like. Maybe I want to, it's too spread out. Let's find up by tens. Maybe I want to go by 5. So I can play around with that if I want to. But if I hover over here, it tells me that there's the frequency of one person answered between 35 and 40. This that little bracket on the 35 means that it includes 35, and then the parentheses on 40 means that it goes up to 40, but not including 40. So if it's 40, it actually goes in the next container. So this one here, that's 5. Anybody that answered 5 goes into the container to the right. So this one technically goes up to from 0 to 4. Or if this was money, from 0 to $3.99, $3.99. Notice that for the student, it tails to the right side. So this is considered a right-tailed shape. It's not bell-shaped. It's not left-skewed. So this is right-skewed, or we say that it's right-tailed. So that's the only thing you would notice from the histogram. Okay, so let's do options, save, and then you're going to call it the histogram. I'm just going to put project summer spring of 24, just so that I keep track of it as it is. And then save it. And once you save it, you could close it and go to the results later, or you can snip it and put it on your document so you have that ready. If it's too big, on your document, make it smaller so everything fits. You could just kind of, with the window, play around with it so you don't have these huge graphs on your documents. So resize them. Okay, everything should be a snippet or a screenshot of the StatCrunch output. I don't want anything like here typed by hand. Okay, after the histogram, there's some more graphs here. We're going to do what's called a dot plot. So it's here, click on that. And then number of haircuts was fine. The point size is just how big we want the dots in our dot plot. Since we don't have that many data, you can deselect this allow points to overlap. That would be handy if we had like a huge sample size, but we don't, ours is in the 30s, we won't need that. And then the same thing here as before. Put your title in there. The X is the number of haircuts from mine, and then the Y-axis is the number. You could put number of students. I don't think you need to though, because let me see if it's applicable. And then compute. So yeah, this gives you the number of students, the number of haircuts. There's that 36. Now, is that an outlier? I don't know, like the mean was, I already forgot what the mean was. So I'm going to go over here. Before I've closed it, they're also hidden over here and results. Like I can go back to it. Here it is, summary. The mean was almost 6. So the center is here. I mean, if you're close to the center, this could be above average, but not unusual. Maybe it's not typical. These might be typical values. At what point do you have to be so far away from the center for it to be unusual? Okay, so again, options, save. It says dot plot. Save it. Now, before I close this, if I kind of go over it with my little cursor here, it trails off to the right again. So again, even from here, you could kind of see that it's a right tail test. Sometimes it's not obvious from the histogram if it's right-tailed or symmetric. So sometimes the following graph kind of helps us with that, which is the box plot. So that's the next one we are going to be doing. So select that. Number of haircuts. We do have to draw boxes horizontally because by default, StatCrunch draws them vertically. And then here we could put the title again. This one doesn't have a y-axis because what you do is you just divide the class into groups of 4. So equal, if like I had 36 in my data set, then 36 divided by 4, that means there's 9 in each part of the box plot. So I don't have to do the number of students. So here I'm just going to put number of haircuts. I'll explain it when we see the graph a little bit more further. So you could, the way we could tell if this is right skewed or symmetric is the distance from the medium, which would be the middle here, to the right is really long, and from the medium to the left is really short. So even if I went like that, it still tails off to the right. What's nice about the box plot is it tells me how many responses were unusual if we're going this route where we say the best measure of center is the median. If you say your best measure of center is the mean, then you have to go a different route. You have to say, if your graph is bell-shaped, then you're not going to say your best measure of center is the mean. You're going to say the best measure of center is I think I said that backwards. If it's bell-shaped, you're going to say the best measure of center is mean. If it's skewed like mine, my best measure of center is going to be the 2. So this is closer to the truth for all LAMC students, because we're going to infer and make a conclusion based on this class as to what is true for the entire LAMC population, because it wouldn't be convenient to survey the entire LA population in LAMC. So what's closer to the truth is that the typical number of haircuts that an LAMC student takes is 2, not 6, because of the distribution of the data. Now, I'm 35 students here, but let's say 36, because that rounds it off nicely to 4 groups. So roughly, there's about 9 students that are between 0 and the first quarter, which is 1. So about 9 students answered 0 to 1 haircuts. And then about another 9 students answered from 1 haircut to the medium, which is 2. And then another 9 students answered from the medium to Q3 with the third quarter, which is from 2 to 6. And then the last 9 students answered between 6 and 13. So there was 9 students that responded between 6 and 13. It's just that the last 9 students, their answers were more spread out versus the first 9 students, their answers were less spread out because mostly but the first 9 students all answered 0 or 1. A more exaggerated case of this was one semester, like when I asked how old you are. If a typical class, the age might be, let's say your average age is 23 of the class. But let's say one semester I had like a 98-year-old student. And if we add her to the average, the average age might have gone up to like 30. And just because she's in there, the typical age of the class is not 30, it's still 23. So that's why it makes sense to line them up so that the person standing in the middle, doesn't matter if I add another person over here, the medium is either going to be, let's say this student was the medium. If I add another student, maybe the medium's like moves one to the next student, but it's still like similar. It's not going to vary as much from the truth versus like if you average it out. So that's why we choose the medium as the best measure of center when you have skewed data. That'll be closer to the truth. But if it's bell-shaped, we want to go 5.8 or 5.9, maybe round it up to 6 haircuts. Now, let's say your data is bell-shaped. How are you going to find the outliers? But you're going to, for the project, you can use these. But for, let's say, exams, usually if we're 2 standard deviations away from the center, that's unusual. So 8.9, like 9, let's say it's 9. So if I take my 6 and I add 9, that's 15. That's the first standard deviation. And if I take 15 and add 9, that's 24. So anybody who's 24 and above would haircuts would be unusual. But we're not going to do that for the project, but there's a difference as to how we do it for the project versus how we do it for exam questions. Okay, so options save if you haven't saved it. It always says box plot. Okay. Now, it turns out that you'll have pretty accurate results. We'll be pretty close to the truth as long as our sample size is large enough. So I had 35. The criteria is a minimum of 30. So sometimes we could do another screening. Sometimes we don't have to have exactly 30. We can actually miss the mark a little bit as long as none of these answers are like extreme outliers. So let me show you how to do that because even though I passed, I don't have to do it because I have more than 30 in my sample size, but maybe there's a student here that had 29. Nobody answered less students answered their question where they didn't make that 30-person mark. So let me show you how to do that. And everybody has to include it. So just in case, we're going to show that. Okay, so you're going to go to graph. And then you're going to scroll down to what's called a QQ plot. And this kind of sees that the data that you've collected when you have a small sample size is fairly close in proximity to each other. So if there's no extreme outlier, you could still do all these graphs and summary steps and everything. So Click on QQ plot. We should meet it because we have more than 30. You're going to go to number of haircuts. You're going to add this correlation statistic. A lot of problems when you get to this on, when you get to those chapters in my stat lab, they change what's on the y-axis and the x-axis, so you might have to do that here. Either one that you do on for our class doesn't matter. Like this one says 8.15. Let me leave it. Let me go. And if you want to go back and you don't want to start from scratch, you could go to, I should have said that at the beginning, go to options, edit, and go back to this page. So I'm going to take this off and do it this way. So I have the normal quartile here and the number of haircuts here. And then if you do the other one, edit, I think this is the one that's more common on StatCrunch. So when they ask you questions and you're checking if your graph matches the one on StatCrunch, look at these numbers here. If they look like the standard deviations, then switch it up if they put the other numbers on the wrong axis. So sometimes they do that. But what you want to take note of is this correlation. I'm going to write it on the side here so that I can 0.815, so I don't forget it. Okay, so you could save or copy and paste QQ plot for, I'm going to put here for class because we're going to do another one for gender eventually. So if you don't put it here, it doesn't really matter because we'll name the other one something different. So, okay, so then we could, so before we close this, I'm going to go back to Canvas, because how do we know we've met the criteria that we don't have extreme outliers where if we did have a small sample, what we would do is that we would compare this number 815. Is that correlation, like from chapter 4, is it strong enough to say that that we can go ahead and use this? Or if one of these so far away from this red line that it's such an outlier that we wouldn't be able to do this analysis. So that's what we're checking. If our number is higher than the cutoff, what we consider is the minimum correlation number that you should pass, then we're good. If this one's too low, then we could still do the project, but we're going to maybe in our conclusion say these results might not be accurate because our sample size was low and it did not pass the condition of the I guess you could say QQ plot. In StatCrunch, they don't call it a QQ plot. I'm trying to think what they call it. They call it something else. I can't think of it right now, but let's go back to check that. That was the survey. You can open the survey again if you don't know what your question is. I'm just gonna. Okay, so on the main first week handouts or handouts for this course, there's this table of critical values. Click on that because you're going to look up your sample size on this. This will be more important when we do it by gender because those will be smaller samples. So I'm going to scroll down. It goes up to 30. So mine have 35. So the reason why it doesn't go above 30 is because we only need to do this if your sample size is below 30. But the correlation coefficient is 361. And yours should definitely be higher than 361. So this is higher than the 0.361 condition met. If this was like a sample size lower than 30, but you could add that because in addition to we found the correlation coefficient larger than the critical value. So that just kind of supports this more that this condition has been met. But did we have to do it? No, you could just, I want that computation done for the project, but we didn't need it. Okay, we surpassed that. Okay, if you haven't, I think we saved it already. I forgot if I saved it. Let me just save it just in case. QQ plot. We could do also for class if you want. I might have already done this. Sorry if I'm repeating myself, but. All right, so that is the requirements for this assignment. And let's see if it's it might be a discussion. Let me just scroll on it really quick. I know it's just something that you're going to upload a Word document. I believe assignment number 5 is where you discuss everything on what you found. And that paragraph that you're going to be writing for project assignment number 5, submitting, eventually that's going to go in your project as well. If you have any questions, feel free to email me.